Hi, this tutorial covers outliers and modified box plots. So let's start with a data set. Okay, pretty large data set, n is equal to 90, so there are 90 data values here. Couple notable things about the data set. Minimum is 30, maximum is 1441. The next largest value is 1068. It seems like in terms of hundreds, like 100s, 200s, 300s, 400s, most of those are pretty well represented. So let's think about some ways of summarizing the data. So a good way to summarize it is using the 5-number summary. Okay, I calculated that ahead of time. So the minimum, like we said, was 30, max was 1441. The median was 559.5, so there was an even number of data points, so we had to take the average of two values. Q1 was 436, Q3 was 739. Okay, now a lot of times when you have the 5-number summary, it's really easy to calculate the IQR. So let's go ahead and do that. Recall the IQR is just simply Q3 minus Q1. So Q3 is 739 minus Q1, 436. If we subtract those two, we end up with 303. So that means the middle 50% of the values in that data set span about 303 units. Okay, let's also take a look now at the box plot. So I've constructed a box plot here. Again, min, Q1, median, Q3, maximum. This distance here, the length of that box, is our IQR, 303. And now the one thing we want to look at is this maximum, 1441. The maximum of 1441 is far away from the rest of the data and seems to give the distribution a positive skew. Okay, remember the next highest value is 1068. This is all the way up at 1441. So that's going to give this upper whisker, it's going to make this upper whisker a lot longer, possibly giving it a positive skew. Okay, so 1441 looks like an outlier, but is it? Okay, remember that an outlier is a data value that is significantly higher than or lower than the majority of the other data values. There must be a gap between the outlier and the bulk of the other values. Okay, so this is just kind of the basic definition of an outlier. Now we do also have more of a formal definition of an outlier, and that's using what's called the 1.5 Iqr rule. So to define that is a data value is an outlier if it is further than 1.5 IQR units away from the nearest quartile. Okay, so if we take 1.5 times the IQR and see if it's either above Q3, that many units above Q3, or that many units below Q1, then it's either going to be a high outlier or a low outlier. So really, to kind of put that into a formula, a low outlier is defined as a number that's less than Q1 minus 1.5 times the IQR. Okay, so this kind of gives us the fence that separates a low outlier from just a regular value. Now, something is a high outlier if it's greater than Q3 plus 1.5 times the IQR. Okay, so these are kind of the cutoff points for outliers. So let's actually calculate those for our data set. Okay, so let's start with the low outlier. We'll do that one first. So low outlier has to be Q1 minus 1.5 times the IQR. And a low outlier has to be smaller than this value. Okay, so if we get those values off of the 5-number summary that we had before, Q1, recall, was 436, and then minus 1.5, we already calculated the IQR also, and that was 303. Okay, so if we calculate that, 436 minus 1.5 times 303. Okay, and what this value is negative 18.5. Okay, so for a number to be a low outlier, it would need to be less than negative 1.85. Okay, and in our data set, we didn't have any negative values, so we're not going to have any low outliers. Okay, now let's do the same thing for a high outlier. So now a high outlier needs to be Q3 plus 1.5 times the IQR. Okay, so Q3, recall, was 739 plus 1.5 times the IQR of 303. Okay, and again, we'll type that into the calculator. So 439 plus 1.5 times 303. So 739 plus 1.5 times 303. Okay, and that gives me 1,193.5. So for something to be a high outlier, it needs to be larger than this value. Okay, so the question is are there any outliers in the data set? And to answer that, there is. Yes, there is. That maximum of 1441 is a high outlier because 1441 is greater than that boundary point that we found of 1193.5. Okay, and of course it is possible to have multiple outliers. So if there were two values bigger than this, then we might have two high outliers. Okay, it's also possible to have both a low outlier and a high outlier in the same distribution. Okay, so these give us the boundaries, and then you just need to consult the data then to determine if there are any there. Okay, now those outliers can help us modify an existing box plot. So a type of box and whisker plot where outliers are identified with dots and the whiskers only extend to the lowest and highest values that are not outliers. Okay, so basically a modified box plot is like a regular box plot, but we use dots for our outliers. Okay, so I'm going to go ahead and construct a modified box plot for this data. Now the first thing I'm going to do is I'm going to identify my outlier with a dot. So my outlier is going to be here at 1441. Okay, so now I'm going to make my my box plot pretty much just like normal. So I'm going to start with the minimum here. Q1 is where my box is going to start. So I'm going to draw a longer line here. My box is going to end at 739, so that's going to be about here. Okay, I'm going to connect these to make my box. So this rectangular region is still just your box. The median of 559.5, that's going to go inside of the box here. So that represents my median. Okay, I'm going to connect this whisker. Okay, now my upper whisker needs to stop at the highest value that's not the outlier. Okay, so that value was 1068. So now my whisker is going to only go out until 1068. I'll make a little hash mark here. So a little bit past 1,000. Okay, and then I'm going to draw this whisker out to here. Okay, so this now becomes my modified box plot. Looks very similar to a regular box plot, but again, we do have that outlier out here marked with a dot. Okay, and then just to compare this box plot to our regular box plots, okay, they're going to look very, very similar, okay, except for obviously this whisker stops where there isn't an outlier. So you're going to see that big gap displayed on your modified box plot. So this is a good way to get a little more information out of your box plot by identifying those outliers. We can also see that maybe there's not as much of a positive skew as we thought by looking at the original graph. All right, well that has been your tutorial on outliers and modified box plots. Thanks for watching.